We can use that to crop and resize images. Okay. So a image crop is actually cutting part of an image out. So if the orange rectangle here is the cropped part of the image, what I have to do is give the crop method 2 coordinates. Okay, I give it 2 coordinates, and notice I have 2 sets of parentheses. Anybody want to take a stab at why that is? Why I have 2 sets of parentheses inside image crop? I'll give you a hint. The outer set of parentheses is what we use to surround the data that we're passing as an argument to the method, to the crop method. Why the inner set of parentheses, do you think? It is, yes, because we're giving it a tuple as a single argument. Why do they do it that way? I'm not exactly sure, but it accepts a single argument that is a tuple. It's a 4-member tuple that says the x and y coordinates of this and the x and y coordinates of this. So if you remember, you might remember from geometry, algebra, or math, whatever, that we always give the x coordinate first and then the y coordinate. So this is 0, 0 in the image, and this is whatever the width of the image is, comma, the height of the image. That's why it's useful to have the image size from the beginning, because then I know what the parameters are of the image. So if I give it 300 and 150, 300 and 150, and 700 and 1000, okay, then I've defined the upper left and the lower right hand corner of the crop. So what it returns is the orange square as a new image object. Okay, so if I want to crop a photo, for example, okay, so here is my image, and I'm back to the buildings. And I'm going to take the image show, and I'm just going to put that down here so it'll show it, because I've got a lot of different image operations here that I'm going to go through. But when I run this code, then I get the cropped piece of the image. So this is the before, right? And then the cropped piece is just that subsection of the image returned back. So that's what crop does. Now resize takes the whole image and makes it smaller or larger if you want. Now larger is a little tricky because everybody ever watched like CSI or like a spy show or whatever, and they have like blurry camera footage, like somebody's caught on a security camera crossing a street like 4 blocks away, and it's like a fuzzy little blur of their face, and they're like, let's enhance that, and it goes, and it's like you can see the stubble on their face. That's not a real thing, guys. You can't do that with artificial intelligence, because you can't take something that's like 10 pixels and make it 1,000 pixels of resolution, because that data doesn't exist. That data has to come from somewhere. If every pixel is defined in a high resolution image, you can take pixels and throw them away to reduce the size of the image, but you can't really take a 10 pixel image and make it 1,000, because that data has to come from somewhere. Now, we have artificial intelligence that we train to predict what a face might look like, but it's still guessing. That data doesn't exist. That you can't enhance a photo that's blurry or that's low resolution by adding that data back, because the data doesn't exist in the first place. Now you can guess at what that data is going to look like using really sophisticated algorithms, and artificial intelligence have been trained to recognize people's faces. But it could be just guessing wrong. So when you're taking a small image and you're making it bigger, just be aware that it's probably going to look kind of crappy. Even if you use resampling, okay, resampling is when we make a small image larger, or even a large image smaller in some cases. It takes a mathematical formula that uses the nearest neighbor, is what that's called, to try and effectively guess at what that data should look like or how that image should look. But resizing images in Python, not super high quality. Mostly you want to go from big to small. If you go from small to big, your mileage may vary, and by that I mean it probably is not going to look that great. So resizing, again, takes a single image or a single tuple as an argument with two coordinates, the new width and the new height. So the way this is working here, you'll notice I'm using floor division on the image.width. So floor division divided by 4, image.height, floor divided by 4. The reason for that is because you cannot give it a float. It takes two integers because you can't have partial pixels. You can't have 3.5 pixels wide. That's not a thing. Pixel is a smallest unit of measurement, so you can't go smaller than that. So it has to be floor division. So image resize. So if I take that image and I resize it to half the size, there's the small one, right? And the original was bigger, right? Oops, didn't want to do that. So this is the small one. Now, you're not going to notice a lot of quality change there, but like if I do this, I resize it small. Let's actually make it really small. Let's make it an eighth of its original size. But then let's take that and let's make it big again. And then we'll show it. Okay, so now let's take that. Okay, so I made it small, which means I threw away, out of every 8 pixels, I threw away 7. And then I take that image and I say, let's make it big again. So let's add that data back. Let's guess. Let's guess at what the pixels are going to be. And you can see that the major impact here is that it is blurry, but you can also see some areas that have been pixelated. Now it's blurry because it's using a formula to try and make it look good, which probably looks better than if I hadn't. But let's take it even further. Let's go to 1/16th the size. So I make it small and then I enhance that, CIA style. So the more I do this, the more pixelated and blurry it's going to get. So that's what happens when you take a small image and you make it big. So just for reference, without me making it big again, here's how small it ended up. So that's the image we're actually working with. And if I take that and I zoom way in on it, those are the pixels that we're working with. So we're going from this to this, okay? So now you can see this is making it large via the algorithm. This is just zooming in on the little tiny image. So all things considered, it's actually not bad. I mean, it's super blurry, but if this is what you're working with, the mathematical formula is actually, doing a pretty heavy lift here. So that is resize. Okay, and again, you can get into resampling if you want. That's useful, but it's just slightly better than without the resampling.